Good morning, one and all. Welcome to another session on data mining. This is Dr. Diana here. And in the earlier session, we have looked into one example of working with a priori algorithm. A priori algorithm is used for association rule mining. An association rule is a frequent pattern given with two measures, mathematical measures called as support and confidence. And we have seen how to calculate support value and confidence value. The difficulty we had in working with a priori algorithm is that for every candidate generation, the algorithm works in iterations. So for every iteration, I have to scan the database once again. And in every iteration, I'm having two phases. One is join phase and the prune phase. In the join phase, I generate all possible combinations of item sets, and in the prune phase, I eliminate some of them if they do not satisfy the minimum support value. So, based on this, every time a candidate generation occurs, I run through this database multiple number of times. And every time I calculate support value, for every combination, I run through the database once. So imagine I've got 5 entries in L2. So for every combination, for each of the 5 combinations, I have to run the database once. So if L2 has got 5 entries, then I have to run the database scan 5 times. If my L2 has got 10 entries, then I have to I have to scan through the database 10 times. So this process increases exponentially when you have multiple number of items. And when your database is large, it becomes computationally very intensive. So in order to avoid that, people came up with another methodology in which if they scan the database once, they need not scan it again. So they wanted to construct a tree structure by scanning the database for the first time, and once the scanning is complete, the tree is constructed and formed and ready. Now every time they want to look up for identifying a frequent pattern or to look up for the support value of a particular combination, all they need to do is look into the tree structure. They need not search for it anywhere else. So that is the idea behind frequent pattern growth algorithm. So the example that we took in the last session was a set of 5 transactions from transaction ID 1 to 5, listing some items here. The first transaction has got MONKEY, the second transaction has got donkey, third is make, fourth is mucky, and the fifth one is cookie. So these are the items. I'm not individually naming alphabet wise. So these are the items. It's a book back problem. It's given in your textbook also. Now these are the items purchased, and they have also given you the minimum support value to be 60%, and they have assumed that the minimum confidence value the pattern should have is 80%. So 80% should be confident that it is frequently occurring. Only then I can consider it as an association rule. So with this idea in mind, I'm going to start constructing my tree structure. This tree structure, construction of FP tree is also iterative in nature. When I say iterative, what I do is I'm going to scan through each of the transaction and I'm going to add them into the tree structure. So for every transaction, I have to scan and do something with the tree structure. Before I start constructing the tree, the first step in Apriori and FP growth are the same. So I'm going to generate all possible combinations of one item set and I'm going to find their support value. Here what are my one item sets? I have already listed in the earlier class, but I rubbed it off, so I'm writing it again. C1 includes M, O, N, K, E, Y, D, A, U, C, I. So these are the possible combination of one item set. Now I should scan through the database and find out the support value of each of them. K is present, support value is M of support value of M is 3 on 5, O is 4 on 5, N is 2 on 5, K is 5 on 5. Seems like everybody who comes to the store has been purchasing K. E is 4 on 5. Y is 3 on 5. D is 1 on 5. A is 1 on 5. U is 1 on 5. C is 2 on 5. I is 1 on 5. So this is my support value. Now, in FP growth algorithm, I am going to arrange these one item sets according to their support value. So in decreasing order of their support value or in descending order, I am going to store these one item set and I am going to refer to that list every time I process a transaction. So I have a priority list to be maintained, and in the priority list, this is my order, which has got highest support value. K has got highest support value of 5 by 5. So my order will be, let me write my order here. Is it visible? Yep. K. And I've got O, E, both of them have support values of 4. Then items with support value of 3 are M and Y. So I've got M, Y, then value 2, N and C. Then all the support value of 1, D, A, U, I. So this is the order that I have to maintain in order to process my transactions. So for every transaction, I am going to look into that order while I am just trying to insert these items inside the tree structure. So my insertion will happen according to the order that I have listed above. It is based on the support value. Now, let me take my first transaction. Transaction ID 1. In transaction ID 1, what are the elements I have got? M, O, N, K, E and Y. So these are my elements. To this element, I have to transform this according to the priority list I have here. So according to this order, I have to list my elements. So it becomes K, O, E, M, Y and N. This is the order in which I have to maintain now. Okay. Now based on this, I am going to draw a tree structure here. Now when I start the tree structure, I am going to start with the null node. So I am starting with the null node, and to the null node I am going to keep adding these elements or items. So when I add, they always add on as child nodes. So the first one is K. To K I have added element O, E, look into this and then keep adding. E, M, Y, N. So these are the elements I have added into the FP tree. This is my FP tree or the frequent pattern tree. Now, all of these I am going to put a support value of 1. All the links have a weight. I have added weight of 1 to all of these links. So with this, my first transaction is complete. What is my second transaction here? T2. When I look at T2, I have got elements DONKEY or the donkey one. So my items here are DONKE and Y. And I should rearrange them according to their support values. So it becomes KO. Refer back to this list, and according to this order I should write this list of items. So KO E M we don't have in this, Y N, and then finally D. Right up? Right, perfect. Now I should try to add this combination inside my FP tree. So I am going to check. K is the first element. Is there a node already in the FP tree where K is directly linked to the null node? Verify. We already have K linked to the null node. So you can consider that this has been added. So K is there. Then O is also there. E is there. To E, do we have a node Y connected to E? We don't have. So from E, I am going to start another diversion. Insert a node here with value Y. So Y is added here. Then to Y we have N, and to N we have D. So these are the list of elements added. All the newly added elements have a weightage of 1. All the previously existing predecessors, I am going to increment their value by 1. So it is going to become 2. So the weightages become 2. Clear? Now I have inserted my second transaction. So this becomes the second iteration of my FP algorithm. Now I should scan my third transaction. What is my third transaction? T3 is make. M-A-K-E. This also I should arrange according to my support value. So it becomes which one? K is available in my transaction. So K. O is not there. E is there. So E. Then M. Then we have A coming at last. So KEMA is the order in which I try to insert inside my FP tree. Now I have to check with my FP tree here. FP tree though, I am checking, is K available as a node attached to the root node? Yes, it is there. From K, do I have another node which is E? No, we don't have. So I am going to add that node here as E. Then again I have to add M to it, then A to that particular structure. To all the new nodes, I am going to give a weightage of 1, and the previously existing node, I am incrementing the value of support by 1, so it makes it 3. Clear? Now I should start reading from the next transaction. What is my next transaction here? T4. T4, the transaction list of items are Mucky. M-U-C-K-Y. I have to order them according to the support value order. So it becomes K, O is not there, E is not there, M, then Y, then I have C, at last I have U. Okay, so this is the order in which I have to insert inside my FP tree. Now come back to the FP tree. In the FP tree do I have K already with the root node, null node? Yes, I have. Do I have M attached to K? No, I don't have. So I am going to insert another node M directly to K. And then I am going to start inserting all its consequent values. Y, C, and U. All of them are going to have support value is 1, and the value of K is going to increase by 1, which is 4. Clear? Now this is the end of scanning of transaction 4. I am coming to the last transaction in my database, which is T5. T5 has got elements as cookie. C-O-O-K-I-N-E. Now, how do I order these elements? K is according to this order. So it is K, O, E, C, and finally I have I. So this is the order in which I have to insert inside my FP tree. Now back to the FP tree. I have K already with my root node. I have O attached to my root node already. But here I've got two O's. Right? Here I do not have two O's like that. So how do I insert? I need not insert it, but I can take the value as twice. So I have to increment the support count by 2 here. So I have K and O. To that, have I added E? E is also there, to which I need to add C. So to this, I am trying to add C, and to C, I need to add I. So the new nodes are only C and I. Their weights will be 1 and 1. E weight I am going to increment only by 1 because E is present only once and O is present twice. So I am going to increment it by 2. So it becomes 4 and K value becomes 5. So this is how I have constructed my FP tree. This FP tree I am going to check if my FP tree construction is right. How do I check that? I should get these support values as listed for one item set if I add all the weightage of these links. So for K I have got 5, for O I have got 4, for E I have got 3 here and plus 1 here, so it is 4. Then I have got N. Where is N here? N I have got 1 here and 1 here. So it becomes 2. So likewise for every support value, if you check, you will get the support value of individual one item sets. In that case, your support value, if it satisfies, your FP tree is right. Now I should look for item sets that have my minimum support value of 60 or above 3. Anything above 3 I can consider as minimum support. So here I have a value 3, and do I have any count which is 3? At level 3 I should have the value 3. This is level 3. E is present in level 3, K, M, Y is present in level 3, K, E, M. This M is present in level 3. Do any of them have a value of support value of 3? No. Only E has got. So only E and its predecessor can form a frequent pattern. So the pattern that I can form is EOK or KOE seems to satisfy my minimum support value. So this is one pattern. I cannot find any other pattern from my tree structure, so it's gone. So this is the only pattern that I can find, and its support value is 3 out of 5. Okay. For finding its confidence value, I again have to check back from my database, scan my database and find out my support value. We have already found that KOE is 3 upon 3. So the same pattern I have generated using an FP tree. So with very less number of scans on the database. So this is how we can differentiate between a priori algorithm and FP growth algorithm. A priori has got only it has got a lot of scans on the database, whereas FP tree does not have. So that's the difference between a priori and FP tree algorithm. So with this, I'll stop here for today's session. I'll catch you up in the next. Thank you one and all. Stay home, stay safe. Looking forward to seeing you all very soon. Thank you.